I almost forgot before we move on to bond lengths and bond energies. Let's talk about deficient octets. It's the whole reason I wore my boron shirt today. So it's a good thing I wore this shirt. I would have totally forgotten. So boron, before we get into this, you're gonna find out why I always call it the most unfortunate element on the periodic table. It wasn't born on home plate. It wasn't born on second. It wasn't even born on first. It was born like in the dugout and never gets out, never gets in the game. Poor boron, unfortunate boron. The Oscar Grouch of the periodic table. It's living in a trash can and no one's helping it out, you know, poor boron. By the way, you know where I bought this shirt? Boron, California, that's right. There's literally a town named after the most unfortunate element of the periodic table. And they have that name because that is where they mine all the borax soap. They literally dig it out of the ground in that area. Very proud of their history of doing that. So just a fun little background on this shirt. Don't know if I'll wear it again for this video series or not, but it's a good thing I wore it today or I would have totally forgotten. So deficient octets mean that there are less than 8 electrons in the valence shell when the whole thing's put together. So for example, let's look at BH3, boron tetrahydride. I'm sorry, trihydride. Okay, so BH3. Let's look at our Lewis structure. So boron only has 3 valence electrons, hydrogen 1, 1, 1. Can't do an expanded octet here. Boron's in the second row of the periodic table. That's it, that is your Lewis structure. 2, 4, 6 electrons around poor boron. It has filled its valence shell. It wants 8 though, it really does, but it can't. You've got to buy in, you've got to pitch in with a friend to get a chemical bond. It wants 4, it doesn't have enough electrons. So the only way boron is able to fill its valence shell in the most satisfactory manner possible by having 8 valence electrons is by having it be an anion. So something like BH4 minus. Well, let's look at that. So we have a total of 3 plus 4, 7 plus 1 more. We're gonna have 8 total valence electrons. And so what we end up doing, this is a polyatomic anion. Like so. So it has to be an anion to have 8 electrons like it would like. Poor boron, no one's helping it out. Like you gotta rob an electron to get by. Poor unfortunate boron. So that's a deficient octet. And then the other thing I realized in the last video, so when we looked at like sulfate, just to clear something up here. So we had this guy was our best structure. And you probably got this from context, but just to be clear, this is a double bond. 2 lines mean a double bond. So there are 4 electrons being shared between this sulfur and this oxygen, and 4 between this one and this one. These guys are still just 2 for each bond. And if you ever see, so there's single bond, double bond, and triple bond. So single, 2 electrons, double is 4 electrons, and triple is 6 electrons. So we won't see a quadruple. That it doesn't happen unless someone really makes it. Someone actually got a quadruple bond once on something. It's one of those things, when it does happen, it's a big deal. But this is it. This is all we're gonna be doing in our Lewis structures. That's gonna carry forward for, you know, here on out. So just be aware that we can have single, double, or triple bonds, and we just stack in an extra line. So single bond, double bond. And then we could have something like N2 over here. That would be nitrogens that are triple bonded together, each having a lone pair. That would be our Lewis structure. So there's a triple bond in the middle here. So just be aware that that's a possibility. That's something you can do. We would run the formal charge on that and we'd see we get a 0 and a 0. Perfect structure. All right. So poor unfortunate boron. I almost forgot to talk about it. That's how unfortunate boron is. Literally got left out of the last video. Poor fella. All right. So that's the end of our Lewis dot stuff here. So we're going to start talking about, now we're going to start talking about bond lengths and bond energies. I'm going to break that into 2 videos, one for length, one for energy. And then we talk about resonance, and that is the end of the chapter. All right. So thanks for hanging in there for one more video.